Hey everyone, welcome back to another interactive codedamn course which is on Vitest. Vitest is an amazing, blazing, fast unit test framework as written on their own website. It's very fast, it's built on top of Vite, which is again built on top of ESBuild, and all these new tools which have been coming out, Bun, Vite, ESBuild, these are like pushing the levels of speed and performance in JavaScript. So it's great to work with something which is much faster than previous generation tools like Jest or other testing libraries. So in this video, in this whole interactive course, which will also consist of labs and everything, we will learn about what Vitest is, why you should consider working with it, and how to write strong unit tests and integration tests using this framework, even in languages or frameworks like React.js. So you can use Vitest to test your React components, and we'll see how to do that. Hey everyone, welcome back, and in this video let's just get and set up Vitest a little bit on our development system. So I'm using Mac OS right now, but it doesn't matter because we'll be working on Playgrounds for the most part. So Playgrounds on codedamn is a free service which you can use to test your code and run your code within the browser. So you can see I've already created a Vitest UI playground over here, which does not include a lot. So let's just go ahead and set up Vitest first. When you create a playground on codedamn by going to codedamn.com/playgrounds, you will be able to choose any of the playgrounds. I've just gone with HTML and CSS because we can construct, and we will construct, a full template from this playground itself. A couple of things inside CDMRC, you can see this is the configuration file of the playgrounds, which consists of tabs and what sort of terminal commands should run by default. So we will play around with this, and I will make this as a template and then give it to you. So you can just visit this link directly. This will be included in the description of this video. So you can just go ahead and set this up yourself. There could be a lab for this, but you can just directly use a playground link as well in the description. All right, so the first thing is I'm just gonna get rid of everything in the directory so that we just start up a little bit clean. The next thing is I'm gonna add, or just initialize a yarn project first of all. Then I'm gonna add a few things. I'm gonna add Vitest UI, which will help us see the UI of the test runs. I'm gonna add Vite, and I'm gonna add Vitest. These three things, you can also add them as a development dependency instead of a proper dependency, but you can see that these three packages would allow us to work with writing tests in Vitest. Next is we need to create a folder. Now this folder could be test folder, but all it has to do is the file names has to end in either test.js or spec.js or something like that. So you can start with hello world.test.js, something like this, right? Now in this particular test file, we can start writing our Vitest syntax. Now, the way this works is you can start using a describe block. Now, I'm just not gonna explain everything right now, but let's just say I'm just gonna write a few syntax and just show you how it looks as a test. I'm gonna save my first test. So here we have a very basic script written and a very basic test written, and I'll explain what that means. But for now, what we have to do is try to run this test, or try to run this folder, all the tests inside this folder using Vitest. All right, so in order to run this Vitest UI, what we can do is include a scripts area in the package.json, and we can say test UI and make this script run Vitest UI, but on port 1337. Now this is something which you have to follow when you are working with codedamn playgrounds. That is, whatever you want to be visible here, it has to run on port number 1337, and it'll automatically get reflected over here. So once that is done, I can say yarn test UI as a script. It will start the Vitest UI on port number 1337. But you can see there are a few obvious problems right here, right away, which is that it says that describe and these things are not defined. I made a couple of more changes to this configuration, vite.config.js, which again we will understand, but we need these few initial changes to get started with the hello world thing at least. And you can see now when I run yarn test UI, which is essentially this command over here, it runs it at a port 1337 successfully. It runs it at a host of 0.0. The only meaning of this is that it is available on all the networks. That means it is available on internet as well. And the test passes, but we don't see anything over here. That is because Vitest is actually running under this path, which is 2 underscores and Vitest. So therefore, in order to see the UI, we have to navigate to this URL. Therefore, for now, what we can do is toggle the browser logs and write that my location.href should be this Vitest thing. And it'll take this iframe into that particular page. We will provide native functionality to change the URL directly from here. But for now, you can just toggle the dev tools, the console, it'll all appear here, and then you can just work with that. So you can see it's a nice UI over here where you can see the test, the whole suite of tests which you're writing, my first test. You can see it says it does nothing. For example, for now, you can see a lot of things from code to module graph to reports and everything. And we'll go into this. You have light mode, dark mode. You can also rerun tests with the UI itself. So it's a nice way to just, keep something while you're developing and keep something on the side while you're developing and just keep a check on what is passing and what is failing. So this is your introductory tutorial of setting up Vitest in the browser in the codedamn playground. I will share this playground link with you. So this is playground and this is currently read only. So you can just fork this playground if you wish to modify or do any changes. Hey everyone, welcome back, and in this video let's just take a look at Vitest configuration options which we set up in the last video as well. So you can see you have a vite.config.js. Now the thing here with Vite is that it shares the configuration file with Vitest, shares the configuration file with Vite. Vite in itself is a bundler, right? And it's a transpiler. It can run your React projects, it can run your Vue projects and so on. It's a next generation front-end tooling system which comes with a server, which comes with hot module reloading and everything. And Vitest is a test runner built on top of this. Now Vite is not a technology specific tool, so it's not limited to just Vue. You can very well run React projects as well. And Vite uses a configuration called vite.config.js. However, because Vitest is also built on top of this tool itself, therefore, it uses the same configuration and same options. So you can see this test block over here is the one thing where I have written globals true. If I remove this right now, you're gonna see that we get some errors in the console that describe is not found or, it is not found. So if you want to fix them without using globals, what's gonna happen is that you would have to import a few things in every single test file from Vitest. So you would have to import describe and it, and once you do that, it'll start working, right? But we can use this globals option to avoid that. And how does that work? That works because Vite can now just inject describe and it manually and all sorts of these test utilities like expect and these stuffs automatically into your system. So you don't have to actually write specific import statements for it. And this is incomplete. This should be 2b and let's say 4. So if this is my test case, 2 plus 2 is in fact 4, but it is not 5. So if I do something like this, then this will fail, right? Because it will say that expected 4 to be 5 and so on, all these error sort of messages. So I will recommend jumping into this configuration document from Vitest from time to time, and you will see a bunch of useful options over here, but we will use them as and when they come, right? You can see there are a lot of options. You can see globals is also something which we just saw. And of course, Vitest just supports out of the box support for TypeScript as well. So if I change all these files to .ts, they will still work. You can specify all sorts of options here from threading to output file. If you have let's say a CI or a runner which needs the output in JSON, we can do all sorts of stuff over here. But we will start by actually learning how to write proper tests and how to write a few things. So that is all for this video. Again, just a quick little introduction to the configuration area and how to work with it. And yeah, that's pretty much it. In the next video, we'll start writing tests, actual tests, and see the configuration options as well as and when they come. Hey everyone, welcome back, and in this video let's just go ahead and write our first actual test with Vitest, because so far what we have done is it's not much. It's testing, yes, but it's not like an actual test or anything. So I'm just gonna go ahead and cut this and actually remove this file as well. Inside the test folder, I'm just gonna create add.test.js, something like this. I'm gonna paste this code, right? It's just gonna say test add function. We're just gonna keep it simple. Test addition works fine, right? Now, what we can do is in in a proper setting, for example, in a real world setting, we can also include tabs as, let's say, src add, or not even src, tests and add.test.js. This tabs is just when I reload this playground, for example, what will run. And then terminal one command could be yarn test UI to boot this up. All right, anyway, not that was required or anything, but just saw it and I just filled the data. So the next thing which we can do is create an src folder and create an add.js function or add.js file here. So I can say function add num1 and num2, and I can just return num1 plus num2. I can just say export default this add function, right? Maybe this is part of our bigger project, which could be React or anything. And now we want to test this functionality. So what we can do, first of all, is import add, or because it's a default import, we don't need to use curly braces, add from src and then add.js. And all I have to do is just say add, expect add, let's say 2 and 5 to be 7. Now I'm just going to explain you as well how this thing works. So when you're working with testing, for example, what you would usually do, the mindset is that you expect a certain function or a certain thing or anything to have a certain type of outcome. It could be equality. It could be sometimes greater than, it could be sometimes less than, it could be sometimes in a specific range, it could be anything, right? When we're talking about numbers. In terms of UI, when you're testing UI, it could be that your UI snapshot, which is like, your HTML structure, for example, of the UI should exactly match a snapshot which you have already provided from a previous test, something like that. So in this case, what we are doing is we are saying that, hey, you should expect that this function should return 7. Right? So what I'm doing essentially is I'm saying that I have a result as add 2, 5, and if result is not equal to 7, then I'm just going to say throw new error, hey, something like this. So basically this is what we are doing. This expect call kind of does this, but we use certain utilities and certain functionalities and testing utilities because it makes it a little more cleaner. For example, if I would have put the condition 8, which would throw this, you can see that we do get an error, but the syntax is verbose, the test fails, sure. But in this case, when we are using the built-in utilities, the syntax is much more cleaner, right? And you can also use something like this, expect result to be 7, that is also fine. But this syntax just allows you to be a little more verbose with what you're trying to test instead of just getting lost into writing code, because now you have to throw new error, you have to use all sorts of if else and all sorts of conditions as well. So testing, when you're testing your code, you might want to avoid that because these utilities are there to help you, right? Similarly, you can, for example, with add, in fact, what we can do is we can just change this to math.js instead of add.js, and we can import this from math, right? And we can just start working on function multiply num1 num2 return num1 times num2, and we can export add and multiply both. Now the way this would work is that we could even change the test name to math, and I can say multiplication works fine. So I can say multiply now 2 and 5, and this should be 10, right? So test math functions, something like that. So now if we see, it says failed to load src add. Let's just give it a refresh, and you can see now that it imports the correct file from src math, and addition works fine, multiplication works fine as well. Both the test case pass, so that's nice. And we just have a single describe suite right now. You can have multiple of them as and when you're testing different features of your code base, for example. And that is how, in nutshell, that is the essence of working with a testing library or a testing system. You define certain conditions, you expect certain results, and you match them with the conditions which you expect. And you use a lot of syntax from the test runner utility itself, right? There is nothing stopping us from writing test manually as well. I can just write a math.add.test.js script in Node.js, which imports and which just asserts like the if-else syntax which we saw. But we don't do that usually. Why? Because test runner provides us with a nice UI. You can see already it can provide us with export results in JSON in different formats, which could be fed to other tools. So that is why we avoid a lot of that work. And while avoiding that work, we also try to use utilities provided by the testing library itself. Hey everyone, welcome back. And in this video, let's just go ahead and take a look at the expect and the matchers basically available in Vitest. Now Vitest as a testing utility uses chai under the hood for running this syntax or for evaluating the syntax. Whatever we have written so far, expect and to be, these two keywords come from chai assertion library, this library. You can see over here, the syntax would seem familiar to you. So you can see we can go over a few things in this video and just get a hang of how everything works. So you can see starting with the first not selection, expect whatever it is to, and then you can use the not to, just negate the assertions that follow in the chain. We want to construct this as a one-on-one thing. What we can do is expect result to not equal 7. Right? If we do something like this, you can see addition failed because expected 7 to not equal 7. If I had this, for example, 8, then this would pass. Why? Because 2 plus 5 in fact is 7, but because we are using not, then 7 not equal to 8 in fact is true, right? If this was equal, then this would fail because it is in fact not equal. It will say expected 7 to equal 8, but not negates it, right? So you essentially get a true statement, therefore the test passes. Another assertion which you can see is a type assertion which is available. So sometimes you might want to check that expect result to be a, and then you can specify a number, for example, like this, to be a string or to be an object and so on. If we change this to string, for example, you're gonna see it fails because it expected 7 to be a string now, right? Let's say for once, if I go ahead and change this to, let's say, just return a string, you're gonna see now our test cases pass. And the reason for that is because expect result now is in fact 7, but also a string, and it's not equal to number 7 or number 8 in this case, right? That is why this test case passes now. But that is not, of course, how you should fix your tests. You should actually fix the, whatever is wrong, not the other way, like, just to make the test pass, you can just fix anything and everything. So for now, you can also assert the type as well. If you're not interested in the exact value, you can just assert the type and call it a day. You can see you can also test for truth and false equality like this. And a good thing about this is that you don't have to constrain yourself all the time into this sort of syntax. You can say something like, let's say if this is, you wanted to test this is a number, this is one way to test it. Another way is to actually use the JavaScript thing, like the JavaScript syntax. You can say expect type of result to be number. So you specified an expression which would anyway evaluate to true or false. And then you can just say to be true, something like this. This is also fine. This is just a little bit more verbose compared to the last one, but this is also fine. Sometimes there might be conditions when you have to check multiple logics and so on. That is when it is fine to just jump into the actual JavaScript world to evaluate and, just do a few things here and then come out of it and just use the thing. You can also say to be false. You can expect this to be string, and this will also pass because it's not a string, right? So that is how these modifiers, that is how these things would work. They just look nice, they just operate properly, they just are easy on eyes to understand. That is why we prefer using them instead of just writing proper code like we used to write in regular code base. But you get the idea, like how to work with them. Okay, let's also talk about the equality thing. So right now, if I go ahead and let's just remove this for now. Let's just say if I have an object as A1. If I say expect the object to equal A1, if I have this code with me right now, you're gonna see that this code actually fails. It says expected A1 to equal A1. But there is nothing potentially wrong in this. Why does it fail then? Well, it is very important that you know this thing in JavaScript if you're working. And we also cover this in advanced theoretical JavaScript and advanced practical JavaScript courses on codedamn. But the reason this fails is because objects in JavaScript, when you use equality on them, are never compared by key value pairs. They are compared with the fact that do they point to the same object in the memory itself. That means they are compared by the reference, not the value. So you can see if I just change this to the main object itself, then this test will pass. Why? Not because these are equivalent, that is true, but that is because this object points to the same object in the memory as this one. A little bit more clarity on this is object 2 is object, let's say. This will also pass. Why? Because object 2 refers to the same particular object in the memory, which is object 1. If I change object 2 to a fresh object, which is, similar to the one which we have above, this fails. So whenever you're testing, it is very, very likely that you will never be able to obviously you need to test the shape of an object, let's say coming from an API or someplace. So what you need to do is you need to do a deep equality check with objects with non-native types like, string or numbers or booleans. With numbers, boolean strings and those undefined and null things, this can work. You can just specify a number, you can just specify a string and so on. But with objects, you need to do a deep equality check like this. So you have to say to deep equal, and then you have to specify the object. So if I add a deep over here, you're gonna see now it works. Why? Because now it actually iterates over the values, keys and value pairs of each of them, and then checks that whether that matches or not. So if I have, let's say, another object over here, it does not match. If I add, the same key but with a different value, it still does not match. And once these objects are again same, it matches. And it doesn't matter that this object is, a JavaScript object directly. You might be thinking that they have the same shape, so that might be a case. But you can just json.stringify and then json.parse this again just to create a truly fresh object. And you're gonna see that it still works, right? Because let's say this is coming from an API, this is your own assertion, and that is how you will work with object parsing. So you can see there are a lot of methods you can use with the chai assertion library. The final one which we can discuss is this expect.fail. So let's say you just evaluated some condition or something down there and you want to fail this test now. One way to do is just using the throw new error thing, which we also discussed briefly. But another thing which is more test focused or just test like is using something like expect.fail. This test should never pass, for example, something like this, right? And you can see that we get this test should never pass and as an assertion error, and that's it. I mean, there are multiple utilities you can go through. I can also leave a link for this page in the description of this video. But yeah, that is the essence of things. You have to use expect. You have to kind of work with the equality somehow, sometimes deep equality in cases of objects and arrays. And most of the times just keep your tests very simple. Follow the rules of the testing utility which you're using, chai, for example, in this case. Go through the documentation to see if you have any specific short code or a short structure to check for whatever thing you're trying to do. And most likely there will exist, and that's it. For basic unit testing, importing a particular function, running it, evaluating the output should be more than enough to test it out. Hey everyone, welcome back. And in this video, let's just actually understand how you should organize your tests. Because so far what we have done is we have done some good work on writing tests, understanding how test logic actually works, and how to use matchers to have certain conditions. But what we have not taken a look at so far is how to organize your tests. So you can see we have already started working with two things here. The first one is describe and the second one is it. Now these two things right here which you see, they're mostly used to organize your tests. Describe is a, it's something like you can see over here. testing math function, which is like a major category. Let's say you are writing some test for checking some payment system of an application, right? So it might as well be possible that you just write here testing all payment systems. And the individual it blocks could be testing a payment gateway. This could be Razorpay, this could be Stripe, the other one could be PayPal, and so on. So what the structure means is that your describe thing should actually be a collection of similar tests, right? They should not be very different from each other. Again, things which I'm saying are just guidelines. They are not rules. So it's not like if you just write some different test over here, it will not work. They're not rules, they're guidelines, but these guidelines will help you keep your test code base clean as well. So you use describe as a single thing to create a block like this, and you put multiple it keywords or it function calls inside this. Now what it does, it is every instance of it is a test, right? So the first argument which you can see is a string, which is a very small and a simple sentence describing what you need to do in this test. Don't keep it a very large string. Don't keep it dynamic. It's not required. You can just keep it a static string. That's it. The second argument is a function call. Now this function over here is important because this function is the test which executes, which is executed by the runner, which is Vitest in this case. Vitest calls this functions and waits for it to either pass, just end its execution, or throw something or fail, like this expect.fail kind of calls. Whenever that happens, it will just mark your test as either passed or failed. Of course, you can also specify timeouts and things which we will discuss soon, but that is how a test block is organized. You can create multiple describe blocks into a single test file, and you're going to see that this also reflects properly in the UI. But for the most part, I would recommend a good practice is that you just create a single describe thing, write multiple tests in it, and that's it in a single file. Then move on to the next file. If you want to create another file, you can just create, for example, this is technically not add, this is math.test.ts, but you can add something else like dashboard feature.test.js as well, something like that. So that will also work. But what you want to do is you want to organize your tests with clear sentence on what it is doing inside clear describe blocks of what the whole category is. And once you do that, make sure you use the platform matchers native features. In the last video, we actually discussed Chai.js, last video, I think, and the matchers in that library. If you want to check additional matchers which are available with Vite and Vitest, you can go to this API reference into the expect block. And you're going to see that we do have a lot of Chai API syntax available, but Vitest also maps the Jest API matchers as well. So this is one thing which we did not discuss, that Vitest also has Jest API available. So Chai syntax, we already take a look, we already have seen. Jest syntax is pretty much the same. It might be a little cleaner because it will not include so many full stops at least, which Chai does. So it's up to you. I mean, at the end of the day, it doesn't matter what syntax you use as long as you are able to understand. For example, this is Jest syntax. And the ones which we used earlier for deep equality and stuff, that was Chai syntax. I would, however, recommend sticking to a single type of syntax to avoid a lot of confusion between libraries or what kind of thing you're using. Again, not that it would be a make or break thing, it's just a recommendation. So yeah, that's pretty much it in terms of organizing your code base, organizing your tests. In the next few videos, we'll start working on some real code base so that we can actually also write real tests for them. Hey everyone, welcome back. And in this video, let's just take a look at why it is actually important to have tests. And we will just reduce the surface area a little bit. I'm just going to get rid of this test. And I'm going to say that our result, the addition, for example, is a little bit complicated. What do I mean by that? I mean that we will create add as a function that can accept any number of arguments. I'm going to say 2, 5, 7, 8. 10, for example, and I can finally say that expect result to equal something like 2 plus 5 plus 7 plus 8 plus 10, right? So this is something which we need to do which is not done right now because you can see that expected 7 to equal 32 because it's just taking the first two arguments. So let's just modify the test first to the source first to fix this feature. So I'm going to go back to the math.js and I'm going to convert this into a numbers thing, right? Which is like a dynamic number of arguments. Then I can say let result is numbers, and then I can say, for example, numbers dot for each num. I can just say result, or this should actually be 0, right? Not numbers, something like this, and then we can just return result. So we now have updated our method, and you can see that the test also works fine. Now the benefit of having tests is something like this. For example, let's just say this add is used somewhere in a lot of places in the code base, and now you have to refactor this test. This function right here is a single unit which has been tested here, right? That is why this is a unit test for this function. So this unit has been tested. That means that we can very confidently refactor this code base. For example, you figured out that for each, the performance of for each is not as good as the regular for loops. So what we should do is probably change this into for loops. So we can say for I0, I is less than numbers dot length, I plus plus. And what you did over here, let's say, is a very subtle bug. Instead of having numbers of I, you just wrote numbers of 0, and then you just returned the result. You can see that this still would return numbers, this still would return something, but this would immediately fail the test because it's now saying expected 10 to equal 32. Why? Because it's adding 2 over and over again this number of times, which is 5 times, right? It's adding just the first argument 5 times. So you would immediately know because there was one test which was passing before, which failed now. So you would never ship a buggy implementation of this function on the production. So you will refactor this, you will figure out that, okay, this was the one which is failing. And you can see now that the test passes and it's all fun and good. And yeah, that's it. That's how you should consider writing tests. That is why you should consider writing tests, because these things happen. Like we have been working, I've been building codedamn. I know internals of writing code. This stuff happens all the time. Subtle bugs can creep in. And a lot of times when you're working with large systems, one thing is related to another. Changing one thing might break some other thing, even though it does not break the first thing in itself. So it's very important to have these tests in place wherever you can, because this just saves the day sometimes. It will just save you so much headache of running into weird production bugs. So yeah, just a simple example to show you that how anything which is related to refactoring might introduce some bugs into your untested code. Therefore, it's always a nice idea to have a testing utility set up in your project and test whatever you can. Ship it in a CI pipeline which runs all these tests before it pushes it to the production. So we will cover the CI pipeline and the shipping stuff later down the line in different courses. Hey everyone, welcome back. And in this video, let's just understand how to write test for all sorts of behaviors. I mean, you should ideally write code in general. For example, this math.js code, you should write code which can never really go into undefined position. What do I mean by undefined state or undefined position of a code? This means that your code is trying to do something which it is not supposed to do. For example, this course is only supposed to add numbers, right? But if you pass in string, it'll still concatenate it, but it will not be something which you would expect to happen, right? So what you should do, for example, that is what kind of test-driven development is as well in a way. You can say addition returns null if non-integer is passed. Let's say you want to define a behavior that, hey, this can only and only accept numbers. If it accepts anything else, then it should just return a null, right? So instead of this, you can just pass instead of 5, you can pass a not a number, for example. And then you can say you should expect it to equal null, right? Now you can see the second test actually fails because actually it is returning you a not a number. Why? Because if you try to run 2 plus not a number plus all these things, it will return you not a number, right? Similarly, you can have, for example, another result 2, for example, and we can have these expect calls like this. We can have an empty string, right? We can have, for example, result 3 over here saying that this is an object which is passed to equal null, right? So what you can see now, if we go into this math.js, we have a bunch of conditions to handle. We can say that, hey, I want if numbers of I, if type of numbers.I is not equal to number, then I just return null, right? We don't even compute the result. We just straight up return null. But the problem here is, as you can see, I mean, in the first case, it still does not pass because not a number, nan actually has a type of number, right? So again, because you are writing test, you were able to find it. If you were, let's say, not writing this test in the first place, you would just do this and call it a day. And then your production code will actually consider this as a valid thing and it will just crash, right? So let me just scroll down in the terminal and let's just fix the first case as well. So what we can do is we can now say if number.is not a number, numbers of I, then also return null, because remember that not a number cannot be compared to itself. That is the only object in JavaScript which is not equal to itself as well. So what do I mean by that? I mean just that if you do console.log not a number is equal to not a number, it'll return false, right? So anyway, now once we have these two checks in place, you can see everything works properly. So this is something which you should also consider, that you should write test for thing to work fine, but you should also try to cover as many cases as you can where the test should not work fine and what it should return, right? Because a lot of times it is possible that you don't control the input of the source itself. A user controls it. And in those cases, you want to just arbitrarily throw any and every sort of input inside of that particular thing, right? Maybe you also want it to limit to a number, a certain number of arguments passed. That could be another test, like passing over 10 numbers returns an error message saying too many numbers, something like that. So this is what test-driven development is all about as well. You decide what all functionalities you want. You write tests for it first, like we have written in this functionality, and then you write the associated code, because it makes it a lot more easier to write code because you have a visual thing of what is failing currently, and it becomes a lot more strong to write proper code then as well, because you have a very strong test case written and all you have to do is just make sure that the tests pass. Hey everyone, welcome back. And in this video, let's just go ahead and take a look at how do you actually test for functions that throw. For example, let's say what happens if I call this function over here and this throws some error, and that is what I actually want to test. So that means I actually want this test to technically pass, right? Because this did the right thing. But if it is throwing an error, then of course this will fail by definition because it just fails every test. So let's just take an example. Let's just say addition should throw on empty call, for example, something like this. So what we can do is we can create a behavior where let's say if I'm adding this add call, I'm calling this add call and I'm saying that if numbers.length is equal to 0, then throw new error, just no numbers specified. But if you think about it, that is exactly what this test is about, right? I want to test that this should throw. So how to do that? Well, if you know a little bit of programming of JavaScript, try, catch and error handling, you will immediately realize that, hey, you can say, hey Mehul, what we can do is we can do something like this, that I can put this in try, catch, error. If I get an error, this is okay. But if I don't get an error, I can say expect.fail, this should have crashed, right? So what we are essentially doing here is that we are putting a try catch block on our own and we are saying we are running something which we expect to fail. In case it does not fail, then we fail the test itself. And otherwise, we just catch the error right here. But the problem here is this. For example, let's say this is not available. Right? This was not available. You can see that this still passes. The reason for that is because expect.fail also throws And this is also this also gets catched by this try catch block, and the catch does not work. So what you then have to do is do something like let test failed as true, or as false. Then instead of using expect fail here, you would have to set test failed as true here, and then outside of try catch you would have to check if test failed expect.fail, this should have crashed, and now you can see that it works properly. But you see that this is so much hassle over what we were supposed to do, right, with a runner like Vitest and library like chai or jest. Therefore, obviously it is possible to avoid all this hassle as well. And what we can do is we can try to work with something like, let's say, let function. This is my function which the assertion library would call, and this is add, right? So we know that when I call fn, it should crash the code, right? It should crash, it should throw some error. But what I'm going to do is I'm going to say expect fn to throw, right? So when I do something like this, I would actually expect fn or this function to throw using chai syntax, or if you want to use jest syntax, you would use something like this, expect fn to throw. Now in this case, if it does not throw, in this case now you see that once I have commented this out, this now fails the test because it's not throwing, right? So this is how it works in terms of, and I think the chai syntax actually needs throw call, so you have to give it a call. Similarly, if I restore this again, you're gonna see that the test starts working again because expect, this syntax is expecting this function to throw. Again, you can use any syntax. You can use the jest syntax if you want, which is this one, or you can use the chai syntax you want, which is .to.throw and then a function call. Both of them work with Vite, so that's pretty fine. But you can now see that how you have to work with functions that throw errors. That is how you assert for them. So yeah, that's pretty much it for this video. I'm gonna see you in the next one really soon. If you're still watching this video, make sure you comment down in the comment section, I watched this video till the end. Also, if you're not part of codedamn's Discord community, you're missing out a lot on events which we organize on a weekly basis to code. You already know the drill. Make sure you like the video, subscribe to the channel if you haven't already, and thank you so much for watching.